Okay, so remember that we've been building up our algebra skills, right? And one of the really important skills that you're going to need is being able to work with fractions in algebra. And here's the good news. The rules don't change just because you have algebraic fractions. What do I mean if I say an algebraic fraction? What makes it algebraic?
It has a letter in it.
It has a letter in it, right? Or it could have more than one letter in it, yeah? Okay, so last time we were here, we talked about what happens when we're using indices, right? And we said that when you multiply, you keep the base, and what do you do to the index or exponent? Add them, right? Did we do that last time? Okay. When you divide, you keep the base, and what do you do to the exponents? Subtract them, right? Okay. So let's just go. So remember that, like, you have a to the 5th times a to the 4th. That's the same as saying a to the 5 plus 4, which is a to the 9. We have a to the 9 divided by a to the 5th. That's the same as saying a to the 9 minus 5, which is a to the 4th. Right? Remember, that was the gist of the whole lesson we did last time. So you're going to need some of those skills today, specifically this one, because we're going to be working with fractions. And anytime you see a fraction, you need to think what operation? Division. There you go. Good. Okay, right? Because in algebra, all division is written as a fraction. So we're going to be working with the rules for division. But what we're going to be working with specifically, though, is multiplying fractions together. So what I want to do is just go back to the rules for multiplying fractions. And I'm going to do something a little bit differently than the way you probably learned it. And it's certainly different from the way that Education Perfect portrays it. Because I know where you're going with these fractions. I know what they look like when you move on into your high school algebra courses and move on into other classes, calculus, etc. And so I want to try to get you to have good habits now, because then it'll be easier just to make things, when things get bigger, if you're in the good habits, then you'll be ready for it. Because when we multiply fractions, typically what happens is we simply multiply straight across, right? And then afterwards, we reduce the answer by dividing away common factors. Does that sound familiar? I hate it. Now, the reason for that is because when you're just multiplying 1/2 times 2/3, the numbers are very small. It's no big deal, right? But we're not only going to have numbers, we're also going to have variables, right? And exponents, and signs, and lots of other stuff happen to us. And as we move forward in algebra, the fractions are going to get bigger and bigger and bigger and bigger. Would you rather work with very, very large numbers, or would you rather work with small numbers? You betcha. So what we're going to do is we're going to toss this out, but not the ideas, not the mathematics. But what we're going to do is we're going to reverse the process, right? So instead, the first step will be to reduce, which is often also called simplify. Okay. First. And again, you're not going to see why right away, why it makes a difference. But you will see why it makes a difference as the fractions get bigger, right? There are going to be some fractions in your high school classes that if you didn't reduce it first, you couldn't do the problem. Right now, it won't look like it matters. But, again, later it will. So it's better to get into a good habit now. So now, while we have little, simple, easy numbers, it'll be easier for us to relearn this a different way. And you also have to remember that when you're reducing, we have more than one fraction, don't we? Because you can't have, if you're multiplying fractions, you got to have at least two of them, right? Otherwise, you don't have multiplication. So we need to talk about what happens for there. We can reduce any numerator. What's a numerator?
The top.
The top number, good. All right, and I want to write that a little bit differently. Any factor in the numerator, And we've talked briefly about that word factor before, but we'll redefine it in just a moment. Any factor in the numerator to any factor in the denominator. Okay? Any factor. Remember, factors mean things that are multiplied together, like 2a. So the factors, that's the same as 2 times a. So 2 is a factor, and a is a factor. Right? Factor simply means anything that's connected together with multiplication. And if they're put together with multiplication, how do you think you'll take them apart? What's the opposite of multiply? Divide. Okay, good. Now, any factor in the numerator to any factor in the denominator in either fraction. So they do not have to be in the same fraction in order to simplify them. As long as we're talking about multiplying fractions, that's the key. Because if it's connected with multiplication, that makes them all factors, doesn't it? Okay? So, what I want to do is I want to look at a few examples, just with numbers first, just to kind of get you back into thinking about how fractions work. So let's look at an example. Say, for example, we have 3/4 times 6 over 15. Doesn't really matter, just making up some fractions. Here is the process that you'll go through. And this is the process that you're going to go through no matter what kind of problem you ever do from this point forward. You're always going to ask yourself first, what operation? If you don't know what operation you have, then you don't have a clue what to do, right? You are never going to understand what you need to get done for that if you don't know what operation it is. So first thing you always do is ask yourself what operation. This one's easy. We see the dot, which indicates what? Multiplication. Okay? Excuse me. Now, second thing, and these are behind the scenes because they're not really even steps to the process. This is what you're always going to do for everything. What kind of numbers? Because these are not 4s and 3s. What are these things that we have up here?
Fractions.
They're fractions, right. And we know that fractions don't behave like whole numbers, do they?
They're naughty.
They are. They have their own set of rules. Okay? Right? So, what you need to do is always remember, ask yourself those questions because that's going to set you up for what to do next. So, what operation is indicated here? With what kind of numbers?
Fractions.
Fractions. So now we can go to the right rule. Do you see the logic there? Anybody ever been lost when they look at the problem and think, oh, I don't even know what I'm supposed to be doing here, right? Well, that's how you fix it. You learn to ask yourself a series of questions that will allow you to focus in on what you need to do. It also, anybody ever tie a string to your finger to remember anything? Y'all don't do that anymore, right?
I cut something blood circulation.
You do something though.
Ooh.
What do you do? What do you do to kind of remind yourself of something?
So when I'm like really tired at night and I remember something, so I have like a mirror in my room. I just kind of like scribble something on the mirror with like whatever pen I've got, and it's kind of bad because now my mirror is kind of covered in stuff.
So you write it down, you tie a finger around your string, you put a reminder in your phone, you do something to remind yourself and trigger your brain to remember that that's the thing you need to do, right?
If you just forget about it.
Okay. Well,
that's not the point.
All right. So that is what these do. Anytime you can do something to remind yourself, because sometimes you think, now stop and think, okay, wait a minute. I can't remember where I left my book. And so you stop and think, and you're not just focusing on the book. What else are you focusing on?
Where you left it.
Yeah, where have I been? What did I do? What have I done? Right?
Where did I go?
Exactly. So you're just remembering all of those tasks that you did. It sets you up to remember what you need to do. And that's what these questions do. They set you up for what you need to do. Now remember, when we're multiplying, the first thing we're going to do is simplify or reduce. They mean the same exact thing. And I'll keep writing simplify and reduce because I tend to say simplify, but in the other class they were saying that y'all learned it as reduce. It means exactly the same thing. You learned simplify?
Yeah.
Perfect, okay? So you'll know exactly what I'm talking about. And remember, we can do it as long as we're doing it numerator to denominator. It doesn't matter which number we use, right? So let's look at these. I'm going to rewrite them so that they're nice and neat. So we know it's multiplication. The first number in the numerator is a what?
Is a 3.
Okay, is a 3. Now, 3 and 4 won't divide by anything, will they? But remember, I can do it any numerator to any what? Denominator. So I can also look over here at the 15. Will 3 and 15 divide by the same number? What will divide evenly into both 3 and 15 at the same time? Well, they'll divide by 3 and you're going to get a 5, right? So now let's divide. 3 divided by 3 makes what? And I usually don't write ones, but you notice that if I don't write the 1, I'm not going to have anything up there, right? So that in that case, that's one of those cases where I have to write the 1. In the bottom down here, 15 divided by 3 is going to leave a what? 5. Excellent. Now, move to the next number, which is a 6. 6 and 5 won't divide by anything, but is there anything in the denominator that will divide with 6? 4 and 6 will both divide by what? 2. So let's divide them out. 6 divided by 2 leaves me a 3. 4 divided by 2 leaves me a 2. And notice that I wrote it very neatly. Yeah? Okay? And if you do, then you don't have to rewrite it every time. But if you don't write it that neatly, then you're going to need to rewrite them. Now, is there anything else that'll divide out? 1 and 2 and 1 and 5, 3 and 2 and 3 and 5? Nope. So that's all the common factors that I have, everything that I can divide away. All I did was ask myself, what will divide evenly into the numerator and denominator? Everybody okay with that? We're going to do lots more, so if you don't worry about it. Then the second step is simply to multiply straight across. Now, what you're multiplying is the stuff that's left, right? Don't go back to your original numbers. So in the numerator, I have a 1 times a what?
3.
Which gives me?
3.
3. In the denominator, I have 2 times 5, which is?
15.
And there's your completed answer. And it will already be reduced or simplified. It will never, as long as you get all the common factors from here, then this one will never reduce or simplify anymore. It'll already be there. Now again, you're trying to figure out why in the world would I go through reducing them first instead of just multiplying across and then reducing. And in this case, it wouldn't have been that big of a deal to take these and multiply across. 3 times 6 is 18. 4 times 15 is 60. And then you could figure out what divides into those. But do you really want to figure out what goes into 18 and 60? Or would you rather decide what goes into 6 and 4?
6 and 4.
You bet. So do you see the thing? Even in this simple fraction, being able to simplify it first made a huge difference. And remember, we're going to be working with algebraic fractions, which means not only numbers, but also what? Variables, right? So the more you can stay focused and organized, in other words, the smaller and more simplified you can make it, the better you'll be. Okay? All right. Let's go to Education Perfect. and look at a couple of these then. So here we go. Immediately, we're multiplying algebraic fractions. They give us one to work on, so we're going to work on these algebraic fractions.
It's the sloth.
I know. I always love how the teacher is always a sloth. What's that about? Billy's. All right, here we go. He's also a pig here. One thing that you need to remember always is that some key words always indicate a certain operation. And in this case, the word of always signifies multiplication. Everybody wants to think of as division, but it's not. It's multiplication. It usually means multiplication by a fraction, 2/3 of the cars in the parking lot, but it always means multiplication. So keep that in mind as you go.
So many things? Or what's that
Well,
word?
in mathematics, of always means multiply. So I see the word of, I know that I'm indicating multiplication. So look at our problem here. It says, let's say we have 3/4 of a pizza, and we want to eat 2/3 of it. So I want to know how much of that's going to be. So it's 2/3 of the 3/4 of a pizza that I have. So that's what they have written here at the bottom, right? 2/3 of translates into what operation? Multiplication of the 3/4 that we started with. Good. So remember our rules for multiplication? Before I multiply, I first what? Simplify.
Simplify.
And that means any factor's numerator to what? Denominator. So, what is the first factor in my first numerator?
2.
Is anything common to 2 and 3? No. But remember, I can use any numerator to any denominator. So what about these two? Is there anything common to 2 and 4?
2.
They'll both divide by 2. Excellent. 2 divided by itself is going to leave me with a what?
1.
And normally I wouldn't have to write the 1, but since there's nothing left, I have to. And 4 divided by 2 makes a 2. The next factor in the numerator is this 3. Is there anything in 3 and 2 won't divide by anything, but what about here and here? 3 and 3? They'll both divide by 3, which is going to leave you 1s. So even though they're not in the same fraction, because it's multiplication, we can still divide even if it's not in the same fraction. Now that I have it all simplified, I just multiply how?
1 times cross.
Yeah, straight across. 1 times 1, which is 1. 1 times 2 is 2. So my completed answer is 1/2. Okay? And we'd prefer to leave, if they start as fractions, we prefer to leave them as fractions. Okay? All right. So, there they go. They work it out. They show you what would happen. If you didn't reduce first, you'd get 6/12, which you could then reduce to 1/2. But it's a lot easier, and especially as things get more complicated, which you're going to see in just a minute. So, let's look at, I don't think there's any reason to look at that one. I don't like it. So let's look at this one. We'll work this one together. All right? So first thing we need to know is what operation is indicated. What operation is that? Multiplication. Excellent. And what kind of numbers are these? Fractions. Good. So we go to our rules for multiplying with fractions, and it says before I multiply, I should first what? Simplify. And that means divide away any factors that are common. Numerator to what?
Denominator.
Does it matter which numerator and denominator?
No.
Nope. As long as you're crossing that fraction bar, it doesn't matter. The first factor, because remember that 8, that all means that those are connected with multiplication if they're stuck together, right? Which means each one of those things is a factor. So we're going to take them one at a time, okay? So, listen to the way I'm asking this question. The first statement. The first factor in the numerator is the 8. Now, 8 and 9, is there anything that will divide evenly into 8 and 9? No. But I could also look at this number, the 10. Is there anything that will divide into 8 and 10?
Yeah.
Yeah, they'll both divide by what?
2.
2. 8 divided by 2 is going to leave what?
4.
4. And 10 divided by 2 is going to leave what?
5.
5. Okay? I know what you mean. You're just getting them in the right. That's all right. Now we'll go to the next factor here. The next factor here is a to the second, right? a to the second and 9, do they have anything in common? No, because the only thing a's can have in common is more a's. Is there an a down here in the bottom of the other fraction? No. So a to the second is not going to change. I'm just rewriting it because otherwise it looks too messy and you might lose it. Be careful. Now there's a b. Is there a b in the bottom of either one of these fractions? Nope. So the b can't change. Okay? Now, there is an a here and an a here. Can I reduce those?
Yes. No.
Why not? They're not one in the numerator and one in the what? Denominator. They're both in the numerator. We can't reduce straight across. We have to reduce numerator to denominator. So be careful. That's why they gave you this kind of problem. The next factor is a 5. 5 and 9 don't have anything in common, but what do you notice about 5 and 5? They'll both divide by 5, which is going to turn them both into what? Ones. Okay. Then there's an a. Is there an a in the bottom anywhere?
No.
Nope. So it's going to stay a. Here's a b. Is there a b in the bottom anywhere?
No.
So it's just going to stay b. Now that I've reduced it all, I'm going to multiply how?
Across.
Straight across. Good. So 4, and multiplying terms, just like we did last time. So 4 times 1 is 4. A to the second times a is a to the what?
Second power?
Remember, it's a to the second times a. Remember that if you don't see an exponent, you assume it to be a 1. So that's the same as a to the 2 plus 1, which is a to the third. Be careful. Make sure y'all doing that homework from the last time so that you can practice these things. Everything builds on what we did before. And then finally, I've got b times b, which is what?
B squared.
B squared. There you go. Remember, it's b times b, which means b to the first times b to the first, which is b to the 1 plus 1, which is b to the second. Go back and practice those. Over, in the bottom, all that I have left is 9 times 1, which is 9. And there's your completed answer. Piece by piece, one step at a time. Don't try to get ahead of yourself. Now, let's look at what they do. What they did is they multiplied everything across in the top and got 40, a to the third, b to the second. Then they multiplied across in the bottom and got 90. And then they looked at all the things that would divide evenly into 40 and 90. Okay, so which looks easier? The small numbers or the big numbers?
Small.
You bet. Take it piece by piece. And again, we're going to move further into algebra. This one didn't have that much algebra in it, right? And so it really makes a difference. Trust me. I know where you're going. Okay? All right. So that goes to me.
Is it compulsory to take Is it compulsory to take algebra when you're older?
You will have more algebra. Yes, absolutely. In 9, 10, and 11, you will definitely have algebra. And then algebra is part of every other mathematical system. Arithmetic built algebra. Algebra is the building block for everything else. So yes, you can't really go any further without it. All right, here we go. So here we've only done with variables on the top. So this one just has variables on the bottom. Do you think that's going to change the process?
No.
Absolutely not. So if we have 2 over 3a times 3 over 4b, again, what operation is indicated here?
Multiplication.
Multiplication. With what kind of numbers?
Fractions.
Fractions. Good.
Excuse me,
So if you're multiplying with fractions, and before you start multiplying, you need to first simplify.
Always simplify.
And it's good. And it's good that you remember simplify, because multiply before you simplify before you multiply, it rhymes, so it's easy to see. So the first factor in the top is a 2. Now 2 and 3a don't have anything in common, do they? But 2 and 4 do. They'll both divide by 2. 2 divided by itself makes a 1. 4 divided by 2 leaves a 2. And notice that I needed to write the 1 up there because I didn't have anything else left, right? Go to the next factor in the top. It's a 3. 3 and 2 don't have anything in common, but if you look at the other fraction, 3 and 3 will both divide by
3.
3, there you go, which will leave you with 1s, right? Okay. Now, there aren't any A's and B's common, so we can just multiply how?
Across.
So in the top, 1 times 1 is
1.
1. In the bottom, 1A, so it's 1 times 2, which is what? 2. And A times B is?
AB.
AB. Can't really multiply them, so you just stick them together, right? That's good?
Yeah.
Got a question?
No.
Okay, all right.
With the education perfect, is that our like main homework now?
It's pretty much all your homework now.
So we don't
Okay.
need to do the math. So do we need to do the math?
Yeah, you're still going to do your maths mates because they're good for review, but the main part of your homework that I want you to concentrate on is on education perfect.
So it's not going to be terrible if we don't get a chance to finish your math mate. Like you're
Not gonna say that.
Well, I don't think you'll kill
Hold on, just one
I know
second.
he
Get
won't, but
back.
like he won't like scream at us.
Well, he won't scream.
And get angry. Okay, I'm used to
Okay.
people screaming at me. People getting angry. I don't want to do. I don't feel.
So the answer to the last one, it was a 1 over 2AB,
Okay.
right?
I live in a family.
Because that's all that we had left, so we just multiplied straight across. Okay? Okay. All right.
You haven't lived in my family.
Now, let's look at this one, but let's do it our way and not the way they do it. So we have 2A over 3A
No, you have my poker.
times 3B over 4B. Focus, guys. Come on.
Sorry.
All right. What operation is indicated?
Multiplication.
With what kind of?
Fraction.
With what kind of numbers?
Fraction.
So when we're multiplying fractions, before we multiply, we
Simplify.
simplify. Any numerator to any
Denominator.
denominator. So what is the first factor in the numerator here?
Hey.
2. Shh, guys.
Sorry, I'm trying to
I like it.
remember. And I'm
2 won't divide by 3, but remember we can do it with any fraction, so the 2 and the 4 will both divide by what?
2.
2. 2 divided by itself is?
1.
4 divided by 2 is?
2.
2. Now, the next factor we see up there is an A. Is there an A anywhere in the bottom?
Yes.
Yeah.
Sure.
And the denominator.
And A divided by A makes what?
A.
1.
Anything divided by itself makes a 1. No, we're dividing, right?
1.
Why are we dividing?
Because your fractions. Going across the fraction bar means divide. You're dividing out factors.
Okay,
So
so
A,
that was divided
guys, okay. So A divided by A makes a what? 1. Remember, this is where we were saying cancel before when we hated that? They don't cancel, they make a 1. But what do you notice up here? There's already a 1. So do I need to write another 1? No.
Right, 2.
So they just, no. So they simply divide away. Okay? Now go to the next factor. What's the next factor?
3.
Is there a 3 anywhere in the bottom?
The one across.
Right there. So 3 divided by 3 makes a?
1.
3 divided by 3 makes a?
What?
1. And since there weren't any other numbers, I have to have the 1s, right? If there's already a number there, do I need to write a 1? No. If there's no number there, do I need to write a 1?
No.
Yes.
Yes.
Okay. What's the next? The next factor here is a B. Is there a B in the bottom?
No. Yes.
Right there. So they're gonna make a 1, but do I need to write the 1?
No.
No, because there's already something there. Okay. Now what?
Now you
multiply
across.
1 times 1 is?
1.
1 times 2 is?
2.
2. And they're using a lot of fractions that end up to be 1/2. That doesn't always happen though, right? Okay.
So it's very simple.
You bet it is. But you've got to remember when to do what. Now on this page, all they're reminding you of is that anything divided by itself makes a what? 1. It does not cancel. It becomes a 1. This one is just division. We've done the division before. They're just kind of reminding you about with what happens with exponents. If you take a to the 7 divided by a to the 4th, we keep the base, and what do we do to the exponents?
Add them together.
When
You
it's
say 7 plus 4. And then.
it's division. Do we add when we divide?
Oh.
We what?
You do 7 divided by 4.
No.
You 7 times 4.
Minus
Not-
4. It's a minus 4. 7 minus 4.
Yeah, because you don't. When you're dividing, what do you do to the exponents? Subtract them. It's a to the 7. It's a to the 7 minus 4, which is a to the third. That's from our last lesson. Remember, anytime you have variables with the same base, you keep the base and subtract the exponents. Remember, because that means a times a times a times a times a times a. How many is that? 6 times a over a times a times a times a. And every time they match, they turn into a 1, right?
It's just a bunch of ones.
Well, no, it's not. So how many are left in the top?
3.
So that's a to the third over 1, which is just plain old a to the third. Remember, we use the shortcut rule. When you're dividing with exponents, you actually end up subtracting them, right? Remember that shortcut? When you're multiplying with exponents, you end up what? Adding them. There you go. Good. Okay? So keep that in mind as we look at the next problem. So they just did the same thing I did here. So here we go. I want you to simplify this one, and you have 1 minute.
Okay.
Go.
Doesn't simplify just mean solve too?
Do the work. Yeah, simplify just means do the work. Yeah. Step by step.
Wait, stop yourself. When you do this, that's 5, right? And then what about
What's common in 10 and 5? What about even in 10 and 5?
You're okay?
10 divided by 5 is
5.
no, 10 divided by 5 is
5. 2.
I remember that time to think about it.
All right. Here we go. Walk through. I don't want an answer. I don't want anybody to tell me an answer. I want volunteers to walk through each step. But I'm going to ask the questions. So you'll be fine. Let me ask the questions. But then we're going to have volunteers to work this step. So first of all, who can tell me what operation is indicated here? Yes? Multiplication. Excellent. Okay, so you've answered a question. We're done. Who can tell me with what kind of numbers? Okay? Fractions. Good. So we're multiplying with fractions. Excellent. So who can tell me then, before I multiply, I need to, yes, simplify any numerator to any denominator. Okay? Good. Excellent. So I'll start you off. The first factor in the first numerator is a 10. Who can tell me if there's anything in the bottom of it, anywhere, that'll divide with it? You finally answer the question. Okay. So 10 and 5. Does it matter that they're not in the same fraction?
No.
No, because it's multiplication. Now remember, multiplication is the only operation you can do this with. What is common to 10 and 5? What will divide into both of them? Anybody?
2.
They'll both divide by 2. 10 divided by 5, and by 5 is 2. They'll both divide by 5. They'll both divide by 5. 5 divided by 5 is what? 1. It's really common to say the answer, not the divisor. Okay. The next factor is an A. Is there an A in the bottom of any fraction? Yep. So that means I can divide that A by that A. And what's A divided by A going to make?
2A. 1.
A divided by A is 1. But do I need to write the 1?
No.
No, because I already have a 2 and a 7, right? I already have numbers there. If you already have any number there at all, you do not need to write the 1. What's the next factor in that first numerator?
B.
Is there B anywhere in the bottom?
Yes.
Yes. B divided by B is going to make a what?
1.
But do I need to write the ones?
No.
Nope, because you already have numbers there, right? If you have any other number there, you don't need to write the 1. Now let's move to the second fraction. The first factor in the second numerator is a 2. In the bottom, I have a 2 and a 7 and a 1. Will either one of those divide with 2?
Wait, what? No.
Nope. So the 2 can't change, right? The next factor is b squared. Is there a b in the bottom anywhere?
No.
Nope. So that means everything divided away that I could divide, and this is what I'm left with. All right? So now I just need to multiply how?
Wait, where did 5 go?
5 divided by 5 turned into that 1, right?
Where's the other 5 go? Oh.
There was, because 10 divided by 5 is 2.
Oh, never mind.
Okay? Now multiply how?
Across.
So 2 times 2 is?
4.
Nothing times b squared just stays.
B squared.
In the bottom, 7 times 1 is?
7.
7. So 4b squared over 7 is my completed answer. Okay? You're going to get lots of practice working with those, so you'll be good. Okay? They just went through it. You'll see what they did was they multiplied everything straight across, and then they started dividing things out. But look at how big the numbers got. 20ab to the third over 35ab. So be careful. Learn to simplify first. It's really going to make your life easier. Okay? All right, let's see what else they have. And here's the reason why it's so much easier to do it first. Look at these numbers. Okay? So, now, because the numbers got big, what did they decide to do?
Simplify first.
Yes, guys.
Well, then why didn't you do it that way in the first place, right? How hard is it to learn something one way, and then all of a sudden somebody says, oh, by the way, don't do that anymore? Then what are you going to do? You're going to go back to the original way every single time, aren't you? Right? It takes a lot more effort. It takes a lot more effort to unlearn something than it does to learn it. And that's why I keep telling you these things. Trust me, I wouldn't mess you up. I know where you're going, so let me get you there the easiest way possible, right? Now, does that mean every math teacher you've ever had in your whole life before me is wrong? Absolutely not, right? It's just there's a pattern to these things that's just ages and ages and ages old for some reason. Does that make it a good pattern?
No.
No, right? If you know you're not going to do it that way in the future, then why learn it that way now? Right? How'd you learn? But sometimes it's good. How'd you learn to count?
1, 2, 3.
Used your fingers, right? You used what's common, right? Now, do you have to use your fingers to count things now? No. But, so you can grow, right? And so that's what I expect to happen here. All right, so here we go. Let's look at this one. Okay, again, we're multiplying, guys, we're multiplying fractions, right? Remember, this is being recorded.
Sorry.
We're multiplying fractions. Before I start multiplying, the first thing I need to do is what?
Don't die. Simplify.
Simplify. Any numerator to any what? Denominator. So, you can do this in stages as well. You don't have to do it all at one time. For example, I see that right here, 240 and 400 both end with what number?
0.
Well, that means they'll both divide by 10, won't they?
Yeah.
So sometimes it's easy to take it in pieces. Look at what's easy. 240 divided by 10 leaves you what? 24. 400 divided by 10 leaves you what?
40.
And already we're way ahead of the game, aren't we? Okay? You could also do the same thing if you see that they all divide by 2. Dividing by 2 is at least going to cut them in half, which makes them a lot smaller. If they divide by 5, divide by 5 is pretty easy. Okay? So look at these two. Now 24 and 40, you notice they're both even, aren't they? So they'll at least divide by what? 2. They'll also divide by 4. If you saw it, they'd also divide by 8. Remember, if they'll divide by 2 and they'll divide by 4, that also means they'll divide by 8. Did you know that rule?
Oh, yes, I did.
So, but let's just divide them by 2. What the heck? That gives me 12 and 20, right? Well, 12 and 20 will both divide by what? 4. Divide, and that gives me 3 and what? 5. So I got there. Did it take me a while? Sure. Would you rather get it right? Would you rather get it fast or would you rather get it right?
Get it right.
You betcha. So let's look at these two. This one ends in 5 and that one ends in 0, which I know means they'll both divide by what? 5, right? So 385 divided by 5. Anybody want to tell me what that is? Y'all got a calculator handy? Because I don't. 385 divided by 5.
77.
Okay. And 440 divided by 5. Remember, if whatever you divide the top by, you have to divide the bottom by the same thing. 88.
77 and 88.
77 and 88 should ring a bell.
7 and 8. No. Okay. No.
Close. 11. Anytime you have doubles, that means 11, right?
Okay,
so
sorry.
7 and 8 is what you get. So you were right there, but they would both divide by 11. Okay?
Yeah, well, like 77 divided
And now look. So in the top I have 7. Will 8 or 5 divide by with anything that have a common factor with 7? Nope. Then I have a 3. Are there 3 anywhere down there? Nope. So I have so what I have now is 7x over 8 times 3y over 5.
Simple.
Anything is now the next thing is an x. Is there an x anywhere in the bottom?
No.
Nope. So I can't do anything with the x. Here's a y. Is there a y anywhere in the bottom?
No.
Nope. Can't do anything with the y. So now what do I do with all that?
Multiply across.
Multiply across. Good. 7 times 3 is?
21.
21. X times y is, hold on guys.
XY.
Good. In the bottom, 8 times 5 is?
40.
And because I reduced it over there, I know that it won't reduce any further. Excellent.